So I understand I have the privilege to be the last speaker before lunch, so thank you for that. So we're doing something a bit different at CC Nuclear and RC14, which I lead. So what is carbon-14 used for? As you say in the first slide, dual usage of Canadian technology. We're not dating dinosaur here with carbon-14. We're doing something a little bit more useful to healthcare and to industrial needs also. So carbon-14 is used initially as a diagnosis tool to diagnose a bacteria in the stomach. So carbon-14 dope urea is transformed into carbon-14 CO2 when the H. pylori bacteria is present in the stomach. So it's a very simple way to diagnose that bacteria that can cause stomach cancer and ulcera in the stomach also. But this is a small part of what carbon-14 is used for. The biggest part is used as a tracer by the pharmaceutical industry and the agrochemical businesses. So it's a regulatory process for approval of every new drug that goes into the markets. It's a well-known method. As Dr. Whitlock mentioned, it's an old isotope that was produced in the 30s and the 40s. So this is a regulatory approval method by the FDA, by Health Canada to approve new drugs. And it's going also to expand the portfolio of agrochemical substances, so pesticide, fertilizer. How do we use them? How do they spread in the environment? Do they accumulate in the cow? Do they accumulate in the river? So we follow the nitrogen cycle of those new substances with the carbon-14 tracer. So it's a well-known usage. However, the worldwide supply is in struggle. So since the Chalk River reactor closed, the C14 production is a monopoly from Russia. As you can imagine, these days it's very problematic to get Russian isotope across the different countries who use it. There's been a start of production in the Qinshan reactor, also in China, but mostly for internal use of that substance for the regulatory approval and not necessarily across the world. So our project is to bring back the carbon-14 production in Canada. And how do we do that? So my colleague and I had a crazy idea of turning nuclear waste liability into a commercial opportunity and not producing new isotope, but leveraging already produced isotope by the nuclear industry. So what we are doing is we are extracting the carbon-14 from one of the waste, which is ion exchange resin, and we are purifying it, enriching it to pharmaceutical grade, higher than 85% concentration that can be used as a tracer. So we're reducing the impact of that carbon-14 already produced by the nuclear industry that is piling up as a waste, and we're turning that as a very good way to replace Russian and Chinese production and bring back that expertise that we had back when the Chalk River reactor was running. We currently have a project with the CMIE, so I want to thank the CMIE for their support with that project. They funded the conversion of one of our space at our facility in Quebec as a state-of-the-art laboratory for producing the carbon-14 product. So it goes into a different substances. The first substance that we'll be producing will be a barium carbonate that can be converted after that and grafted to the specific drugs for the tracer, and will expand the portfolio as broader molecules with larger potential for the radiochemist to use. So thank you, CMIE, for that support. What makes RC14 innovative? It's the opportunity that we saw in turning that liability into a commercial opportunity. And I want to thank also OPG, Ontario Power Generation, for supporting our craziness with that project. So thank you to Chris Orn and his team, Nicole in the isotope commercial division, who believed in turning that waste into useful, beneficial reuse of that waste for the life science industry. So this is what we do, and we want to expand. Any ideas that you may have in turning a waste stream into a valuable isotope, not producing new isotope, but leveraging what is already being produced by the nuclear sector, this is our expertise. So come and see us, come and discuss with OPG folks on how can we help you develop and support your research by leveraging already produced isotope. The last thing, so what is next? What's next for RC14? It's the beta voltaic batteries. So imagine a batteries that keeps its power for 5,000 years, because that's the half-life of carbon-14. So you can imagine using those batteries into space application or remote location application that you don't want to change the battery, or in medical devices such as pacemaker. You could imagine in few generations we'll share the pacemaker from generation to generation to reuse that carbon-14 power. So we're working with a company to incorporate that carbon-14. Since it's a carbon-based, we can use it as a diamond. So we're actually generating diamond from a nuclear substance from carbon-14, and we're generating powers from that carbon-14. So this is what's next. It's not directly linked with a medical usage, but we see a huge potential in developing whatever other crazy ideas can be supported by those beta voltaic battery. So that's what we do at RC14. That was a short presentation because I know you enjoy lunch, so.